Hi everyone. So today I'm going to talk about AZ-700 exam. So this exam covers how to design and implement Azure networking solution. So in this exam, I will cover the three videos. The first video I will talk about a networking overview. In the second video, I will talk about the security overview, and then in the last video, I will share some practice test with you, which will help you for this exam. So if you're preparing for this exam or you want to learn Azure networking or Azure security, then this video is for you. So let's begin. So when you plan for Azure adoption, so when you plan your company plan for to go to cloud because of some motivation, because of some purpose, right? In that case, as a network engineer, you have to create a landing zone. Landing zone is a very critical piece because landing zone will decide how we are going to create this network, how we are going to connect to this network, what kind of traffic coming to this network. Okay, so a lot of things are there. So normally the traffic could be the traffic coming from internet. So you need to provision resources in such a way that you can accept the traffic from the internet as well as you can send the traffic to internet back. Second thing could be like you have multiple resources inside the Azure network, and you want to make sure that they can communicate with each other without any challenge. The third thing is that you have offices, they also want to connect to Azure resources, or you want to create hybrid mode where you have few resources will be in on premises, few resources would be on cloud. So that kind of communication you need to enable for this. So for that, the first step here is that you need to create a virtual network that will be also called a VNet. So when you create your new subscription, you have to create a resource group. After that, the first step is to create a virtual network. So which I have shown over here like 10.0.0.0/16. So that is my network range for this virtual network. Let's understand this range in more detail into the next slide. Into the next slide, here is we are talking about the address space. So when you create a network, you have to define an address range. You can see there's a class A, class B, class C, class D, and E. You can see a five classes that they divided the IP address in such a way. So as per the RFC 1918, you can take this kind of IP ranges for your network. There is no any restriction that you cannot use any other IP range, but these are the routable IPs associated with the class A, class B, and class C. So it's always recommended to use these IP ranges for your VNet. The next thing you need to understand is that about the IP reservation. So when you even though you create even though you can take any range, five IP address being reserved from the Azure. So you can see that dot zero assigned to network address, dot one assigned to default gateway, dot two and dot three assigned to DNS internal DNS IPs, and then dot 55 is assigned for network broadcast address. So other than that, you can take any range or you can take any IP. So for example, if you create a first virtual machine, so that will start from dot 4. Similarly, you can see there is a few ranges is not available for you because that is being used by Microsoft. Okay, so in that case, you can see the multicast address, broadcast address, or loopback, link local. This addresses is not available to you. This is being used by Azure, okay, or even the Microsoft. So you always skip this IP address from your designing. And then last one is the 168.63.129.16/32. This IP again is a virtual public IP address which is being used from the Azure platform services for communication. So this IP address you cannot use in your design. Let's move on. Now, the next point you need to understand about subnetting. So when you create a VNet, you cannot put your virtual machine inside the VNet. You have to define the subnet. Subnet is nothing but logical partitioning of the entire range. So this range get divided into multiple small groups. So that is we call subnet. So you can see the subnet, the subnet 00, subnet 01. You can subnet 00 is assign this IP address, and the range is 248. Then you can say subnet 01, the IP address range C 10.0.0.1.0/24. You can see 250 IP address available to you. Okay, so this way, as long as you start using these IP addresses, this number will go down. Okay, similarly you can see a gateway subnet, storage subnet. So you can define your network in such a way that few subnets is assigned to servers which is being used for particular purpose, and few subnets assigned to some other resources according to that. So for example, subnet 0 where I'm going to keep my web servers, for example, and this web server is going to talk with internet. So this subnet, maybe I will assign a public IP to virtual machine, or uh, I will assign a load balancer or any other way to by which I can go to internet, and even though I can expect traffic from the internet also. In that case, this subnet we call as a public subnet, because this subnet or the resources inside the subnet will talk to internet. So that's why we call it public subnet. Other name to this subnet is also DMZ subnet. You also heard about this as a dematerialized subnet. Okay, so those subnet or those resources which you don't want to talk to internet, that subnet we call a private subnet. So that there is no any provision to create to go to internet via that private subnet, like your application server, database servers, which is the backend of your entire product. So you don't want to publicize that in that case. Okay, so similarly, a subnet you can give any name, but few resources, for example, I give a category over here: network category, web category, data category, container category, hosting category. In this category, if you create a resources like application gateway, VPN gateway, Azure firewall, Azure bastion host, so these services you have to take a dedicated subnet. You cannot put this resources into any subnet. It is not allowed. So when you uh, create these resources, so beforehand or while creating these resources, you need to give a dedicated subnet. It will tell you also that this create subnet with this name. So name is defined. So you have to take that naming convention. Similarly, you can see a web server, database server, sorry, web so set category where you can see API management, web apps, app service environment, Azure Logics app. So you can take that option, right? So for this kind of services, you need to take a dedicated subnet. The same thing follows with for data containers and hosted. Now, IP address and public IP association. So when you create any resource, the private IP will be assigned to that resource. So take example of virtual machine, a load balancer, application gateway. So the IP assignment can be done via dynamic, or you can do a static also. It's up to your choice. So they both options available to you. Similarly, for public IP address also, for virtual machine, load balancer, even the application gateway, the IP can be assigned dynamically or static. For few path-based services like Azure Firewall, NAT Gateway, there is no provision to assign IP address dynamically. You have to take a approach that you have to create a IP address first, and then IP address will be assigned to the these resources. Now coming to DNS zone. So when you go to Azure and you want to create a DNS service, you have two options. One is a DNS zone, other one is a private DNS. So DNS zone is mostly used for the public domain, and private DNS is for internal domain. So for example, if you see this is a screen, right? I have taken a domain sagarcloud.cf. It's a public domain I have taken, and I want to publish a website like appserver.sagarcloud.cf, and I know that my server will be hosted into the Azure. In that case, I will host this public domain through DNS zone. So this DNS zone will provide me their own name server, SOA servers, through which when a request come to this particular website or DNA domain, this request get resolved via this name server, and request traffic will go to the app server. Okay, so my DNS query will get resolved faster in this case, because my backend also into the DNS Azure, and my names are also in Azure. Okay, the other option is that when you take any domain from the domain registrar, they will also give a space to host the domain on their end as well. It's up to your choice whether you want to go with a DNS zone, or you want to go with the DNS hosting service available at a domain registrar. Similarly, you have multiple servers into the in your VNet. So here I'm talking about a private DNS. So you have multiple resources created into the VNet, and the resources want to talk to each other, but you don't have any inter DNS. And in that case, you can create a contour.com. I'm just taking an example of this domain. I will create a private DNS with contour.com, and I will create a record, okay, for this particular VMs. So for a record I will create. So if VM1 want to connect to VM2, then the request will go to this VM2, but the request will first go to your internal DNS server. This will resolve, and it will give you a IP address, and via IP address request will go to the VM2. Okay, so there is a link, virtual link is options available through which automatically the resource allocation will be happen, automatically the record creation will be happen. Okay, let's move on. Okay. So one more thing, before going to the link section. So I have already created a video for this zone, DNS zone and private DNS zone, because I have taken this screenshot from my previous videos. We want to understand the how to set up this and understand more detail about it. Then you can see my YouTube video. I have given a link into description. So please refer that. Similarly, the endpoint. So if you have created a private or sorry, you have created the pass-based services, and you want your a virtual machine or any other resource want to connect to each other, so you can use a help of, or you can take a help of service endpoint. So for take example of the virtual machine, and the virtual machine want to put a data to the storage account. So you want to connect to the storage account via private channel. So you can take a help of service endpoint through which you can directly connect to the public gateway of the pass service, and you can put a data. So the storage account is one of the service you can take, for example, and this service storage account come with a public gateway. So this public gateway you can use to allow your virtual machine to connect to that resource via service endpoint. Similarly, private endpoint also available option available to you. For example, you don't want to sleeve the network. You want that your request to will be inside the your VNet. So in that case, what you can do, you can create a or you can assign one IP address to this storage account. Okay, you can create a private endpoint basically. So this request will go to this private endpoint, and this endpoint will send a data to the storage account. So your data will get more secure over here. Understood? Yeah. So similarly, I have created the separate video for this. I have taken this screenshot from my previous YouTube video. You can I will give a link for that also. You can refer that to understand or to see how to set up this search endpoint and private endpoint. Now, moving next for VNet peering. So in a VNet peering, you can see there are multiple options available for you. So first option, you can understand that if you have a two VNets into the same region, and both VNet have a separate different range, and you want to connect to each other. So in that case, you take a help of regional VNet peering. So if the both the VNet inside the same region, then you can take a help of regional peering. And if in case you have a VNet, for example, take example of hub VNet and VNet B, both are in different region, and you want to talk with each other. So then in that case, you can set up a peering, but that peering we normally call a global peering. Okay, so that option you have. If again, if the both VNet into the same region or different IP range, then you can use VNet peering to connect to each other. If the both VNet in different region and using different IP range, then you can take a help of the global peering. Peering only works if the IP address of the VNet is different. If the IP address of the both the VNets are overlapping, in that case you cannot use the peering. Okay. Now next, UDR, user defined route. For example, you have private subnet and you want to connect to internet, for example, or you want to send the data to internet. But you what the thing is that you cannot send any data to internet. You want to filter that data, or you want to check the data before sending to internet. In that case, what I will do, I will create one user defined route, and I will assign this route to this virtual machine, and this virtual machine will, because of this UDR route, request will go to NVA. So NVA is a network virtual appliances. It could be firewall. In this firewall, we have created a filter. We have created a rule. So when the request will go wanted to go outside, this NVA will validate the rules, and if the rule is allowed to go out to that particular site, then this only the request will go out. If that particular rule is not created for that website which you want to connect via this channel, then this NVA will not allow you to connect to internet in that case. So through NVA or through with help of UDR, you can restrict the traffic going to internet. Now the third section or third point here, that you have a VNet inside the Azure and you want to connect to on-premises. So you need to configure the remote gateway. So the remote gateway here is a VPN gateway. which will work as a your uh, router. So this VPN gateway will send the data to the on-premises via this path. Okay, so VPN gateway will be used, and we also call this a gateway transit, which will be used to send the data to cloud, or send data to even the on-premises. Okay. Now we'll understand network address translation. So, for example, you have VMs in the private subnet where you don't have an internet, but your VM have a operating system, and that operating system you need to update the patches, you need to update the hotfixes regularly. For that purpose, you want to go to internet, or you want to connect to the Windows update server or Linux update server, for that matter. In that case, you can use take help of the dat. So you can create this service is a path based service, and you can map this service with a subnet. So via this, your subnet or the VM inside this subnet will go to internet and download the patches. Okay, so this NAT will provide you the outgoing traffic only. Okay, so for example, if somebody want to connect to this VM via this NAT, it is not allowed, because this NAT is only allowed to go out. It will not give any option to for connect to this VM via NAT. Okay, so this is the beauty of the NAT. It will give a provide a security to your VM. The only thing which is the drawback which I can see about NAT is that you cannot filter out. So when you enable the NAT for your virtual machine, so this NAT will allow you to connect to all the websites. It will not control which website you can access, which website you cannot access. This is not allowed. Okay, so this is just a temporary provision to update the patches, or to download or any particular software for short period of time. Okay. Moving next, hybrid connectivity. So, for example, you have a offices, you have a on-premise offices, you have a headquarters, and you want to everybody want to connect to the Azure. Similarly, you have employees working from home or remote location. They want to also connect to Azure. So you need to take help of the private connectivity. Over here, you have option as a express route, or you can take help of the S2S, set to site VPN tunnel, or even though you can take a help of P2S, point to site VPN tunnel. So the express route is a more reliable, more secure, and provide you the dedicated link between the on-prem to cloud. So you can take this express route when you are looking for reliable and private connectivity between the two different offices, or two different setup, on-prem headquarter and the Azure cloud. Okay, the second option is that a side-to-side VPN tunnel. In case you need to keep a backup as well, in case because you taken this service from service provider. If in case there is some issues or some line cut, because it is at the end it is MPLS link. So in there is some issues with the service provider, and it goes down for short period of time, then in that case you have a backup link, so that your business won't get impact. Okay, because of that. So in that case, you can take a help of S2S as a backup link. It's again internet link. It will not give you the higher bandwidth. It will go your bandwidth. You will give a bandwidth up to 1.2 Gbps per second. And but the data traffic going through this channel is encrypted. Okay, so same thing, same approach you can take for branch office also. You can set up a S2S VPN tunnel, so the data will go out. Okay, and data through which you can connect to the your Azure network. If you are employees or customers accessing these resources via internet, so you can also you use the VPN client. You can ask them to use a P2CS P2S VPN tunnel, to which they can connect to the Azure resources. The three options available for you. Now, taking this forward, if you have an enterprise company, you have offices across the globe. You have offices, your existence into the cloud, as well as you also exist into the on-premises, and everybody want to connect to each other by a common link. Okay, so you want to set up a hub and spoke kind of architecture. In that case, you can take help of this virtual WAN. It is a very powerful service, and it will give you a consistent performance. It will give a consistent network to all your resources. So through virtual WAN, all your headquarters, branch across the globe can connect it to this service via express route, via S2S link, via P2S link. Even though they can connect to each other via same channel also. Okay, so everybody can connect to each other via this common link and send the data. Okay, so the network bandwidth also get saved, and the cost also get saved via this path or via this approach. Moving next, now, last option is that what load balancing. So, load balancing is very critical piece when you're designing your network solution. You need to understand this in more detail. So, uh, in case you have a public website and you traffic is coming to the website regularly, but if there is a peak, there is more traffic coming to your website, then you will make sure that, or you want to make sure that your site will be available 24/7 to all customers, even though it is a peak time or not peak time. In that case, what you will do, you will use a load balancer through which you will distribute your traffic at a backend, so that when a request come to your websites, then the traffic get equally distributed, so there is a less load on your backend server. I mean to say backend application server, so that the CPU memory utilization will not go high, and because of that, this won't crash. So because of the load balancer, you can maintain the high availability of your applications. But you can even though take an example of Amazon Big Sale. So Amazon Big Sale also use the same. They even though there's a high traffic, they use a load balancer at the end to take receiver traffic. And load balancer through load balancer they distribute the traffic across the a node. Even though they use automation technique, auto scaling also to add a more and more node at a backend so that more requests can be handled. Okay. So now let's move on to the services piece. So load balancer is a service which is available right now. It works as a lower layer 4. So if you know about the OSI model, Open System Interconnect. So in that model, at layer 4 is nothing but a transport layer. It's covers the TCP UDP protocols. So if you're looking for TCP UDP protocols, ports to be allowed, so you can take help of this load balancer. Similarly, there is application gateway. It works as a layer 7. It is application layer. So if you have websites which is taking the traffic over the internet, so you can use this application gateway to handle the traffic. Even though you have option to enable or to configure the SSL TSL certificate also. So this load balancer I am just as a categorized as a additional load balancer, just for simplify or to understand your design. Now moving next, in case you want to spread your load, if in case you have your workload is span across the region and you're looking for load balancer, so in that case you can take a help of global load balancer, which can be span across the region. So first in that category is a traffic manager. Traffic manager can be used to handle the load on your sites. For example, you have production and DR site, and you want both sides to be available to customers. Even though the product side goes down, your load balancer handle the traffic and redirect the traffic to a DR site, which is a which you want to make it available for that time. Okay, so through which you will there is no impact on your application because any downtime or because of any issue at the production site. Okay, so traffic manager work on the DNS level. So your DNS query will be handled through this traffic manager, and they use their as per the configuration. There is a configuration like performance or weightage or priority. So based on that, you can configure your traffic manager, and via this the traffic will be handled. So beauty of all the load balancer is that they have a health probe option. Why health probe? They keep checking the backend servers. If the backend server is available, then only traffic will go to that servers. If the backend server is not available or goes down, then the health probe will fail, and because of that, the health load balancer will not send traffic to that particular node. It will redirect the traffic to some other node. Similarly, you have another option, front door. Front door you can use for fast acceleration or high performance, because this front door use a edge network. So you're looking for a regional load balancer. Sorry, you're looking for global load balancer who can give you the best performance. In that case, you can take help of the front door. It is IP based load balancer to use. So to just to categorize this load balancer, we can call this lookable load balancer. So front traffic manager front door you can use if you want to distribute the traffic or between the different regions. Okay, so this is all about the services of Azure. Let's understand about exercise. If you want to prepare for this exam, then Microsoft also provide you some option to exercise all these services. So let me show you that. So this is a link which I'm going to share with you in the description box. So this in this link, you can see all exam details. You can see what are things are going to cover in this exam, and then you also, even though you can schedule exam as well. Okay, but my purpose to show you this site is that I want to show you the exercise. So if you go down, there are two options you can get. The one self paced means you can do it by yourself, or you can also take a instructor led exam. Okay, so this particular option also available with you. So in self paced, you can get a more idea. You can go to theory also. You can do a practice as well. So let me show you one. So if you go here, then you can go down and you can see all the topics listed over here. Okay, so you can take one topic at a time, and then you can go through the theory first, and then you can also do exercise. Let me show you one exercise over here. So in this exercise, you can see what are the labs, or they will give a lab scenario to you. They will show you architecture diagram, and then also show you objective. What are the tasks they're going to cover into this lab? So task one, task two, task three, task four, and task five. So five tasks are there here. Now to understand this, how you're going to achieve that, then you can just click on this, and then you can click on start. So
Welcome to this interactive lab simulation for the lab Design and Implement a Virtual Network in Azure. To navigate this interactive lab simulation, follow the prompts on the screen or use your forward and back arrows. Contoso Limited, a fictional organization, is in the process of migrating infrastructure and applications to Azure. As a network engineer, you will plan and implement 3 virtual networks and subnets to support resources in those virtual networks. The Research VNet virtual network will be deployed in the Southeast Asia region, near the location of the organization's research and development team, which will use this virtual network. The team has a small. Next, select Create. Next, add the subnets as shown.
can you see that? It will give you all the options.
Verify the configuration passed validation, and then select Create.
Can you see this? Okay, it will give you the instruction how to create a resource. uh,
This task is now complete. Click the screen to continue.
can you see this? It's very easy.
Return to the Virtual Networks page. Create a virtual network with the settings as shown.
Okay, let me stop this. So I hope you got the idea, right? So you can click on this instruction, and you can follow the instructions step by step, and then you can create a resources with help of this stimulation lab. I hope you understood this session very well. That's it for all.